Welcome to Network Professionals, the Cisco Networking Academy, your perfect training and certification partner. We offer online and offline international certification courses like IT Essentials, Networking, Cybersecurity, Network Security, and Cloud Computing. Our today's topic is about Wi-Fi standards, history and evolution of Wi-Fi standards. Key features of modern Wi-Fi standards. Applications of Wi-Fi standards. Emerging technologies. Future of Wi-Fi. Wi-Fi standards are the technical specifications that define how wireless networking devices communicate with each other. They are created and maintained by the Institute of Electrical and Electronics Engineers, IEEE, under the 802.11 family. The original Wi-Fi standard supported speeds of up to 2 megabits per second on the 2.4 GHz frequency band. While groundbreaking at the time, it was limited in scope and efficiency. Released alongside 802.11b, this version introduced the 5 GHz frequency band, providing higher speeds, up to 54 megabits per second, but with a shorter range due to higher frequency signal attenuation. Combining the best of 802.11a and 802.11b, 802.11 grams supported speeds up to 54 megabits per second on the 2.4 GHz band. It quickly became the go-to standard for Wi-Fi networks. This was the first standard to operate on both 2.4 GHz and 5 GHz bands, enabling dual-band operation. It introduced MIMO, multiple input multiple output technology. Operating exclusively on the 5 GHz band, 802.11 AC delivered speeds up to 3.46 gigabits per second. It introduced features like beamforming, MU-MIMO, multi-user MIMO, and wider channel bandwidths, up to 160 MHz. Wi-Fi 6 brought significant improvements in efficiency and performance. It operates on both 2.4 GHz and 5 GHz bands, supporting speeds up to 9.6 gigabits per second. Frequency bands. Wi-Fi operates primarily on the 2.4 GHz, 5 GHz, and now 6 GHz, introduced with Wi-Fi 6E bands. Each band has unique characteristics. 2.4 GHz, longer range but more prone to interference due to overcrowding. 5 GHz, faster speeds with less interference but shorter range. 6 GHz, offers high-speed connectivity with minimal congestion, ideal for modern networks. Channel widths. Channel width determines the amount of data a Wi-Fi channel can carry. While earlier standards used 20 MHz channels, modern ones support up to 320 MHz, enabling higher data rates. MU-MIMO and OFDMA. MU-MIMO allows multiple devices to communicate simultaneously, improving throughput. OFDMA subdivides channels into smaller subchannels, optimizing bandwidth usage for multiple devices. Beamforming. This technology focuses the wireless signal directly toward devices instead of broadcasting in all directions, improving range and signal strength. Power efficiency. Wi-Fi 6 introduced TWT, allowing devices to schedule when they wake up to send or receive data, reducing power consumption for battery-operated devices. Applications of Wi-Fi standards. Home networks, enterprise environments, public spaces. Emerging technologies. Wi-Fi 7 will play a critical role in supporting applications like AR, VR, autonomous vehicles, and the Internet of Things, IoT. As Wi-Fi continues to evolve, it will address emerging needs for higher speeds, lower latency, and greater reliability. Upcoming innovations may include Wi-Fi sensing, allowing routers to detect motion or measure distances. Enhanced integration with 5G networks for seamless connectivity across wireless and cellular technologies. The development of Wi-Fi standards will also play a key role in bridging the digital divide, providing high-speed internet access to underserved regions.